So this is the stacked block problems regarding normal force. So the first one says the magnitude of the normal force exerted on block A by block B is one of these choices. So we said it was C because the magnitude of normal force exerted on block B by block A is equal to one another, and that's because due to Newton's third law of interaction, when there's one force, there's always an opposing force that is typically equal. So we said it was C because the force pushing up on B should be equal to the force of A pushing down on B. And then 2, we said B, but the correct answer was supposed to be C because it was regarding like the magnitude of the weight of A in regards to B. We said that it was less than because the force of the block is heavier, therefore like the force exerted by A should be greater than B. But it turns out that A's weight is just regarding the gravity. So the gravity that's acting on A is actually the force that's pushing on B. So in return, due to Newton's third law again, B would have to push up with the same amount of force. So it turns out they're supposed to be equal. And for 3, we got this one wrong too. It's just a rewording of 2. So this is supposed to be equal as well, because again, since the force of gravity of A is pushing on B, B has to push up with the same amount of force due to the third law. And then 4, we said is equal to the magnitude of the normal force exerted on B by the desk, because since we are not discussing weight and the acceleration is 0, the forces should be equal to 0 due to Newton's, this is supposed to say first law, I'm sorry. It's due to Newton's first law, because since this is moving at a constant velocity, the acceleration is 0, and that would mean that the forces, or the vectors, would have to equal to 0, so the forces should be equal.